This is a recording of how to work each of the review problems on the test review that I handed out to you. Now these problems are the same problems, but they have different numbers. So if you have questions about the problem on your particular sheet, just follow the procedure that I use on here, and you will be able to use that same procedure on your problems. Okay, so let me get color. I think that'll show up. So let's take a look at the first one. Convert 20 degrees, 58 minutes, 19 seconds to decimal degrees. And if we remember when we did this in class, we took the first number plus the second number divided by 60 plus the third number and divided by 3600. By doing that, that will give us our decimal approximation to that value. The result you should get is 204 degrees and 0.97, or 204.971 degrees. Okay, now let's look at number 2. Find the angle of least positive measure in degrees, not equal to the given measure, that's coterminal. And remember, coterminal means they land in the same position on our circle, if we think of it as a circle. So I'm going to draw a quick little picture here. Negative 236 means we have to go in this direction 236 degrees. Well, I know when I get to here I'm at 180. So I'll need to keep going. When I get to here, I'm at 270. So negative 236 is somewhere in this second quadrant. So we'll call that negative 236. I'm asked to find an angle that's coterminal with that, but has the least positive measure. So I want to find this angle here that has the smallest positive measure, but lands in the same position. How's that done? Well, if I take 360 degrees and subtract from that the 236, that will give me the amount that's left over right here in the red area. So if I subtract those two, I get 84 degrees. So the angle from here to here is 84 degrees. And now I think I may have messed up. Found my mistake. On my calculator, I typed in 236 as 276. So 360 minus 236 is 124 degrees. So the angle of least positive measure, that's coterminal, is 124 degrees. Let's check out our next one. Find the angle of least positive measure. That's coterminal with A, and A is 415 degrees. So let's get an idea of where that is. So we're going in the positive direction. Well, I know this amount is 360. So it's obviously past 360. How much is it past 360? Well, let's take the 415 and subtract 360 from it and see what we get there. Okay, so when I subtract those, I get 55 degrees. So this angle goes around once and goes a little more and stops at 55 degrees. So a positive 55 degrees is coterminal with a positive 450. Let's check out this pulley rotating thing. So a pulley rotates through 95 degrees in 1 minute. How many rotations does the pulley make in an hour? Well, I know that there's 60 minutes in an hour. So in 60 minutes, it will have gone through 60 times 95 degrees, it'll have gone through that many degrees. So it will have gone through 5,700 degrees in 1 hour. Now the question is, how many rotations is that? And one rotation is 360 degrees. So if I take the 5,700 and divide it by 360, that'll give me how many rotations it makes. Okay, so I get 15.83 rotations, and it says to round to the nearest whole number, so that will round to 16 rotations per hour. All right, let's check this next one out. Got a triangle? We want to find the measures of the angles in a triangle, so we have to start with the basic knowledge that triangles, the angles in a triangle add up to 180 degrees. So what are my three angles? Well, one angle is 3x minus 30, plus another angle is x plus 30, plus the third angle is 1/6 x plus 55. So if I add all three angles together, set that equal to 180, I can find the value for each angle A, B, and C. So work on solving that. When we solve this equation, we get x equal to 30, so we can find our three angles. For A, it's 3 times 30 minus 30. For B, it's 30 plus 30. And for C, it's a 1/6 times 30 plus 55. And you'll notice 60 degrees, 60 degrees, and 60 degrees for each one of those angles. So we're looking at an equilateral triangle. So let's check out our next one. Parallel line. We have a transversal cutting through those parallel lines. We want to find the measure of those two angles. And if we remember, vertical angles have the same measure. So this angle has the same measure as that angle. And not only do vertical angles have the same measure, but corresponding angles have the same measure. So this guy corresponds to that guy, so they have the same measure. So the equation I need to set up is 2x minus 26 equal to x plus 2, and I can find the value of x. Consequently, find my two angles. So solve it and find your two angles. You'll see that they're both 30 degrees because x turns out to be 28, and they have to be the same value since they're vertical angles. Okay, here we've got similar triangles, and if we remember, in similar triangles, the sides are in proportion. So side 12 is in proportion to 4. This 12 is in proportion to A, and 15 is in proportion to B, so we could set up some simple proportions to solve that. 12 is to 4 as 12 is to A. Well, this one's kind of obvious. A has to be 4. But let's go with the other one. 12 is to 4 as 15 is to B. Can you figure that one out? Well, you may need to do a little solving, but see what you get. Well, when this one's solved, we should come up with B equal to 5. So A is equal to 4, B is equal to 5, and that makes these guys in proportion. You could also look at it. You might notice that if each of these are divided by 3, divided by 3, divided by 3, you get a 4, and a 5. So several ways you could notice that. Okay, we got a tree casting a shadow. Love drawing these sweet little pictures. We got a tree. We got a shadow. And that shadow is 32 feet. And we have a vertical 6-foot pole. That's casting a shadow. That's 4 foot. And here is 6 foot. And we can use the same principle of similar triangles to find the height of the tree. So we'll call the height of the tree x. So x is to 6 as 32 is to 4, and you should be able to solve that. Yeah, x is 48 feet. Oh, one more similar figure, but this one's actually inside another figure. So it may help to take this guy and extract him out. So I've got this little triangle here that has a 60 and a 20. And then I have the big triangle where this side is x and this side would be 120 plus 360, which would be 480. So I have enough to do my comparisons. 480 is to 20 as x is to 60. And you can solve that for x. Should get x equal to 240. I made a mistake right before this. I had placed this as the number 20, but it should have been 120, so I fixed my mistake. So the value of x is 240. Let's go on to problem 10. Sketch an angle. We got a point, and then we want to find the trig functions that go with that. So let's pick the sketch that has the point 5, negative 12 showing that angle. Well, you go right 5, you go down 12. That means it has to be this guy, right? You go right 5, there's my 5, you go down 12, right 5, down 12, there you go. So there's the angle, angle B. Now with this angle, that 5 and that 12 give me a value for x, a value for y. I need to find the value for r. So 5 squared plus a negative 12 squared equal r squared. So take time to find r. So the ordered pair gives me my value for x and y. I'm using the Pythagorean Theorem, so I need to find the value of r, and in this case, r is 13 when I square root both sides. So with those values, we can set up our 6 trig functions, x, y, and r. R is 13, x was 5, and y was a negative 12. Make sure that's right. Yeah. You got to have this part memorized, whose sine, cosine, tangent, what they are in terms of x, y, and r. So sine is going to be negative 12 over 13. Cosine is going to be 5 over 13. Tangent is going to be negative 12 over 5. And you can just finish the rest of them by doing your reciprocals. So I'll let you finish those out. 13 r over y, is that it? So it'll be 13 over negative 12. Let me finish it up. 13 over 5. Oh, there we go. And then the last cotangent will be negative 5 over 12.